All right, today we're going full CSI on this thing. We're going to peel back the layers of history and physics to figure out exactly how this legendary and frankly terrifying artifact of the nuclear age came to be. So let's dive in.
So let me ask you this. What's the most dangerous artifact on Earth? For a long, long time, the answer was just two words: the elephant's foot. But what even is it? I mean, it's not some ancient relic dug up from a tomb. Nope. This is an artifact we made, and it forces us to look at what happens to, well, to matter itself when you push it to the absolute limit.
Okay, so picture this. Deep inside the ruins of the Chernobyl plant, there's this thing. It's a massive, solid flow of what you can only describe as man-made lava. It's totally unnatural. And that's our goal here today. We're going to trace its origin story. We're going to figure out the exact step-by-step sequence that created this monster. So to really get this, we've got to go back in time, all the way back to its moment of birth, April 1986. We're talking about the seconds and minutes right after the explosion, deep inside the superheated, chaotic mess of the reactor core. That's where the story begins. I mean, the temperature in there, it's just staggering. We're talking over 2,600 degrees Celsius. Just to put that into perspective for you, that is almost half the temperature of the surface of the sun. Yeah, in that kind of insane heat, the normal rules of chemistry, of physics, they just start to break down. But here's where it gets really interesting. You'd think the nuclear fuel just melted, right, from all that heat? Well, not exactly. See, pure uranium dioxide actually melts at a temperature that's even hotter than the core was. So what happened? A wild chemical reaction kicked off. The zirconium metal that was clouding the fuel rods, it started reacting with the uranium, and that created something called a eutectic mixture.
So what on earth is a eutectic mixture? Well, it's actually a pretty simple concept. Think about when you put salt on an icy road. The salt makes the ice melt at a lower temperature, right? It's the same idea here. The zirconium was like the salt, and it just slammed the melting point of the fuel down by almost 1,000 degrees, and that's what allowed it all to turn to liquid and start its insane journey. So now you have this molten mass, which scientists call corium. And once it escaped the reactor, oh man, it became this ravenous chemical soup. It just started dissolving everything it touched, adding all these new ingredients to its destructive recipe. You've got serpentine from the shields, concrete from the foundation, even the sand and clay that the helicopters were desperately dropping to try and stop the fire. It all just got mixed in. And this was the crucial moment of transformation. The corium wasn't just melted nuclear fuel anymore. By gobbling up all that other stuff, it had totally changed. It was reborn as this silicate glass ceramic magma. Basically, it became a man-made lava, super rich in silica, and it was ready to start moving. And this new man-made magma, wow, it was not only incredibly destructive, it was also surprisingly mobile. So, for the next part of its story, we're going to track its journey. A destructive path right through the guts of the power plant, on a path that they now call the Great Horizontal Flow. Just think about this for a second. To get out of the room it was in, the corium had to go through a reinforced concrete wall, a wall that was 2 meters thick. 2 meters. It didn't punch a hole in it, it didn't break it, it just melted its way right through. That just shows you the kind of unbelievable, sustained heat energy we're dealing with here. And this quote here, it gives you such a stunning mental image. Scientists who studied its path actually said it moved just like a certain type of lava you'd see in, say, Hawaii. That smooth, ropey-looking kind called pahohoho, just relentlessly pushing forward across the floors.
Okay, so let's actually trace its path. It starts by pooling up in room 305/2. Then, bam, it melts through that 2-meter concrete wall we talked about. From there, it spills out across a couple of corridors until it finds cracks and holes in the floor, things like steam pipes, cable conduits, and it just cascades down to the floor below. But this crazy journey couldn't go on forever. As the magma got further and further away from the insane heat of the core, it started to lose energy. And this is where we get to the final chapter of its creation story. This is where the unstoppable flow finally stops, and a legend is born. So as this man-made lava poured into this new, cooler corridor, it started to stiffen up.
Its viscosity, which is basically just how resistant it is to flowing, it went through the roof. So instead of spreading out in a thin puddle, it started piling up on itself, kind of like really thick honey. The front of the flow would cool and solidify, basically creating a dam that the rest of the lava piled up against.
And as this big lumpy mass finally cooled down and hardened for good, its surface got this really distinct look. It was wrinkled, it was textured, it was this gray-black color, and it looked, well, uncannily like the folded skin on an elephant's leg. And just like that, its famous nickname was born. So, when you think about it, from those eutectic reactions to becoming silicate magma to flowing like lava in Hawaii, the creation of the elephant's foot was this incredibly complex, violent, geological process that all happened in just a few days. And now it just sits there, frozen in the basement, a silent monument. But its story, man, its story is a powerful, powerful reminder of the incredible forces we've learned to command and the terrifying consequences when we lose control.